Hi everyone. In this example, we will look at how to create facets for multiple relationships. So before we get into this, let's understand what facets are. Now, we have something called facet grid. And if you want to Google it, you can see the explanation, the classes, and the different parameters that are inside. But I want to give you some simple examples to help you understand how to work with these. So in the first example, we want to initiate a 2 by 2 grid. Let's see how we do this. So import cborn as SNS and then SNS dot set. So our style is text, and we will also keep our color codes as true. Then we will select the data set. So load a data set, and we will select the tips data set. And finally, SNS dot facet grid. Our data set is tips. The column is equal to time, and the row is equal to smoker. So what happens here is we get a result like this, and very clearly you can see that there are 4 grids that have been created. Now imagine you want to draw a univariate plot on each of these facets. So we want to create a univariate plot. So from matplotlib, we will then say that G is equal to SNS dot facet grid, and if I can copy this entire thing, and then we say G is equal to G dot map and plt dot hist would obviously be histogram, and we have the total bill. So this time we have the 4 grids, but we also have a histogram inside there. So we can see smoker yes, time lunch, yes and dinner, smoker no, time lunch, and no and dinner. Now we can also pass additional keyword arguments to the mapped function. So let me use numpy for this, and let's create some bins. So we say np dot a range, let's say 0, 65 and 0, or let's keep it 5, not 0. All right, so we can copy these 2 lines, and the change that we want to make here is that we will write plt.histogram, which is great, and we have the total bill, after which we also want to say that bins is equal to bins, and let's say our color is equal to any color, let's say green. So we write G here. So we run this and we get, now you notice that we are seeing the bins as well, right? So if you look on the x-axis, you can see it's from 0 to 65, and obviously you can change it to any number that you want like this. So let's keep it at 65 right now. So 0 would be the starting point, 65 is the end point, and 5 is the interval size. All right. Now let's look at a bivariate. Right. We'll copy these 2 lines once again. So this is okay. The first line is okay. And in the next one, let's create a scatter plot. Obviously, you can't create a bivariate with a histogram. And we will keep no bins now. We will keep our tip value. And let's keep the edge color as any color, let's say B. So the result looks like this. And of course you can change the edge color. So let's make it white. I think that would look better. In fact, let me try yellow so that it looks more prominent, right? Like this. So this time we have a scatter plot with total bill and tip represented on the X and the Y axis. Now let's assign one of the variables to the color of the plot element. So copy and paste. So we want to keep the hue as the smoker. And then we want to say PLT scatter, total bill, tip, edge color. And after this, we will also have to write dot add legend. And it says there is an indent problem. Let's quickly see why that is happening. Oh, you know what? We don't actually need this. So let's just keep it like this. Wait a moment. Okay. All right. As you can see, we have total bill on the x-axis, and then we have lunch and dinner represented as two different visuals. There was something else I wanted to show you. So let me just quickly check my notes and see what is it that I wanted to show you. See, if obviously right now you notice that the size of these visuals is not very large. Now, obviously you can change that, but there are different ways of doing it as well. Let's take an example. Let's say we have, which one should we take here? Or you know what, let's do it in the next one. Let's see how we can change the height and the aspect ratio as well. Let's do one more example. So here I want to show you how to change the height and the aspect ratio. So we will say that G is equal to SNS dot facet grid, and then tips column is T, and then we can say that the height is equal to, let's say, 4, and the aspect is equal to, let's say, 0.5. Then we say G dot map or PLT histogram total underscore bill, and then we have bins is equal to bits, like this. Now obviously these can be changed, so you can change the height and you can also change the aspect. So if you make it 1, then it becomes a little wider, like this. So very simple, but still something that I wanted to cover for you. You can also specify the order for the plot elements. So we'll say G is SNS dot facet grid, and I'll just copy the entire thing. So that would save me some time. Let's copy the entire thing. We only want to change the column order. So let's say the column order is equal to, so first we want the yeses to come, and then we want the no's to come, like this. The rest would be the same, and let's also choose a color here. So we'll keep the color as, let's say, magenta, right? And we're not getting a result. Let me just quickly check. So call, okay, I'm choosing my call as my smoker. Perfect. So we can see we have smoker yes and no. We can see the column order as well as yes first, and then we have no. All right. You can even use a different color palette if you want to. So let's say you want to use a different color palette. So again, don't bother about all these syntaxes that I'm writing here. When you read the documentation, it will all make much more sense. Some of these obviously we have done earlier, but because there are so many parameters here, it would not be possible for me to cover every single one of them. But the good part is that once you understand the basic idea, learning the others is not really that difficult. U is equal to time. Then we have the palette, which is equal to, let's say, set1. Now remember, this is an inbuilt keyword, so there are different types of set patterns that are available. So we'll keep our hue order is equal to, so we'll have, let's say, the dinner coming first, followed by the lunch, and we will keep a height of, let's say, 5. Then we have g.map, plt.scatter. We want to keep our total bill amount, and we also want to keep our tip here. Wonderful. So once we have done this, it says there is a problem. Let's just quickly check. There should be g.map. Wonderful. So we are able to see a result like this. And as you can see, there are different palettes available. So if we change it to set 2, you get a different set of colors altogether. All right. Now you can also use a dictionary mapping to map the hue colors. So dictionary mapping for hue colors. The link I'll be sharing with you, I'll just show you how it looks. Let me open my browser. Just give me a second. All right. So the link I'll be sharing with you, but this is Python graph gallery.com, this one. So this is not on the official Python documentation, but you can see the 100 different colors that are available here. It's a fantastic list with a lot of interesting colors available. All right, let's come back to our example. So let's see how we'll do this. I'll just give you a small example. Let's say that is equal to dictionary where lunch is a specific color. So I'll use spring green. This is one of the colors which is there. And we will say that our dinner is, let's say, gray. Once we've done this, we can just copy the rest, come back, and we'll have to make a few changes here. So hue time, and then we'll say that our palette is equal to the colors that we have defined. So it would be pal. Height is okay, the hue order is okay, and I think everything else is correct. As you can see, we get the two colors that we selected. So spring green and gray. Like this, there are different colors here. So if you want, let's say, medium orchid, you can just come here and type medium orchid, and I get the exact two colors on the vision. All right. You can also use a different axis. So you want to use different axis labels after the plotting. So we have facet grid. We'll use tips. The column is equal to the smoker, and then we have the row which will be equal to the sex, and then we have g is equal to g.map plt scatter total underscore bill. Then we have the tip. Let's keep the color as, let's say, green. And then we're using keyword arguments here. So again, if you are not aware of what keyword arguments are, just make sure to Google it. Once we've done this, we can then say set underscore access, and then we have labels, total bill, and US. Of course, you can write anything that you want to. So writing US dollars. Let's close this and then let's write the tip. And there is a error with the indent. Let's just see why that is happening. One moment, everybody. Okay, so I think it looks all right now. And why is it coming two times? Okay, I think I have copied it two times. So you can see now the result looks like this, right? So total bill US dollars, what you see at the bottom is the x-axis label that you're able to see. All right. We can also set other attributes that are shared across the different facets. Let's copy our previous couple of lines. And then we will use a PLT scatter, total bill, tip, color, everything is okay. Let's change the color to red just for some variety. And once we have done this, we don't want the access label right now, but I want to say dot set and xlim is equal to, let's say 0 to 60. This should be 0 comma 60. And then we have the y limit, which is 0 and 12. Then we will keep the x ticks, which is the tick mark, at 10, 30, and 50. And similarly, we'll keep the y ticks as, let's say, 2, 6, and 12. So now you notice we have also defined what is the x and the y axis tick marks. Very handy. So this allows you to do a lot of customizability in your visuals. If you want to reduce the, let's say, increase or decrease the white space, we call this tightening the facets. Let's copy this. All right, just one small change that I want to make here. I want to keep the margin titles as true so that I can see the margin titles all the time. All right, so everything seems to be okay. We have our text. The only change we want to do right now is that we want to write dot fig dot subplots underscore adjust, and now you can define the white space. This would be w space 0.5, and then we have the horizontal space, which is, or rather the hue space. Let me just check what these are. So we have the W space and the H space in Seaborn. Okay, so we have the W space and the H space here. I just want to check what the parameters are, which I can't seem to find right now. So we have the H space and the W space, but you know what? I still can't find what they stand for. So I think the best way to do this would be to simply run it and then try to modify it. So we can see the spacing here. I think this should be, if I understand correctly, the white space and the horizontal space. Let's just double check. Okay, so if I make it 1 and if I make it 0.1. Okay, I think you will have to figure this out on your own. I'm not really sure what this is doing. But the W space, as you can see very clearly, is reducing the space between my two rows here. So for example, if I make it 0.2, very clearly, you notice that there's a little bit of space here. If I make it 0.5, we have a space. And if I make this 0.5 also, you notice that the space is increasing like this. We can also use a different template for the facet titles. Right? So let's say we want to change, I want to show you how you can change the column wrap. I'll explain this in a moment. So G is equal to SNS dot plot. I'm sorry, what am I writing? So G is equal to SNS dot facet grid. We have tips, then we have column, which is size, and then we have the column wrap. Okay, so this is a variable that I'll be changing later. So let's keep it at 3 for now. And the rest would be very simple. We say G is equal to G dot map. PLT, we want to create a histogram. Tip. Then we have our bins. So np dot a range 0, 13. And let's keep the color as anything, let's say yellow. Then set titles. Now look at this part carefully. We will have to make a curly brace, a curly bracket, and in this we will write the column name and we will write diners. So once we have done this, the result will look like this. So you notice we have a column wrap at 3, which means that we will only have 3 columns. If I make it 2, then it gives us 2 columns. And similarly, if I make it 4, then it gives us 4 columns. So a lot of customizability for you to play and interact with. Additionally, you can also use a different marker for the hue levels. So SNS facet grid, tips, then we have column, which is sex, we have hue, which is time, and then we have palette, which is equal to pal. Then we have the hue order, which is, remember we did this earlier, so we want to keep the dinner first, and then we want to keep lunch. Then we have hue.kws, which is dictionary marker. Okay, now this is the marker, and you can choose from a different few options here. So I'm choosing, let's say, a plus sign, which I'll write inside a double quote, and then I will also use a down arrow. So I'll just type a V here, like this. Let's also keep the height as maybe 6, and let's keep the aspect as 1, so that the visualization becomes a little wider. Once we've done this, we have g.map, plt.scatter, we have total bill, then we have tip, and then we have KWS, and then we have dot add legend, All right, so we have a nice big wide visualization here. You can see that we have two different markers. So we have a plus and a down arrow. If you wanted to change this, you could have changed this as well, like this, right? So to experiment with this, you can use your own color palette, you can choose your own order, and you can choose, of course, the height and the aspect. All right. So one more example. I want to show you how you can wrap a column with many levels into the rows. So wrap a column with many levels into the rows. So we'll just use a different data set here. Again, an inbuilt data set. And this is called attention. So G is SNS dot facet grid, ATT. Our column is our subject. Our column wrap, okay, is let's say 6. And then we have the height at 1.5. Once we've done this, G is equal to G dot map, PLT dot plot, solutions, score, and we will keep our marker as a period. All right, so when we run this, the result looks like this. So we have 6 columns and we have defined the height here as well. So of course you can change that as well. Right, and you can see a result like this. Wonderful. So we have understood quite a lot of how facets work, and we want to look at multiple relationships with facets. So remember, that's what we were originally doing, facets for multiple relationships. All right, let's again take a simple example. Just a quick recap. So SNS.rel plot, my X is my total bill, Y is my tip, and then we have the hue as the smoker. Column is time and data is tips, right? So we get a nice visual here. We have done this earlier, just a quick recap. Now we can also show the influence of two variables this way, which means that one is by faceting on the columns and the other is by faceting on the rows. So as we add more variables to the grid, we may want to decrease the figure size. So remember, we have the height and the aspect ratio. So again, we have done this earlier, but a slightly different example. So SNS.rel plot, and we will keep X as our time point. We will keep Y as the signal, and we have the hue as the subject. Our column is our region, our row is our event, and our height is 3. Finally, we want the kind to be a line. We want the estimator to be none, and the data would be, you would have known this by now, is the fMRI dataset. So when we run this, this is how the final result appears. So we have all these different subjects here, and it's a very clean way of presenting the data. Let us do one last example. When you want to examine effects across many levels of a variable, it is a good idea to facet the variable on the column and then wrap the facets into the rows. So we have rel plot. X is my time point. Then we have Y, which is the signal. We have our hue, which is the event. Our style is also the event. Then column is subject. The column wrap is, let's say, 5. The height is 3. The aspect is 1. And the line width is 2.5. Finally, the kind is a line. The data we're selecting is our fMRI data. And I'm only looking at region, which is, let's say, frontal, like this. Perfect. And there is an error here. Let's quickly check. Okay, I forgot to close the double quote. So as you can see, we get a result where we have 5 different columns here because that's the column wrap, right? So it's a very clean way of presenting these small charts. Wonderful. So everybody, that concludes our final topic on statistical relationships. So we have seen how to relate variables using scatter plots, how to emphasize continuity using line plots, and finally, how to show multiple relationships with facets. In the next lecture, we will see how to work with categorical data.